Hi everyone, my name is Vinh. In this series of videos, I would like to share with you how to implement embedded programming on microcontroller 32-bit, which is based on ARM Cortex-M core architecture. In my series, I'm going to use Renesas RA4E1 microcontroller to implementing and practicing. Mm, So, mm, what's the reason and why should I choose A41 microcontroller? Let me introduce. First, A41 based on ARM Cortex-M33 core with maximum clock frequency at 100 MHz. It supports large amount of flash memory, size up to 512 KB and surround size is 128 KB. It supports various protocols, skill elements, encryption, high integration, high performance, and high reliability. Here is a list of connectivity. It supports various protocols like I2C, SDI, SPI. SCI stands for Serial Communications Interface. Mm. QuickSPI, QuickSPI stands for Quest Serial Peripheral Interface. Mm. It's, um, it's for communicating with external flash memory using SPI. So next is USB 2.0 full speed and control area network is CAN protocol. About security and encryption, it supports ARM threshold for data protection and security, hardware software isolation. In summary, it's sufficient for you for learning and practicing with many applications. Uh, Here is its purpose of my series. In this series, everything will be start from scratch. I will aim to beginner and anyone who is at basic level. I will give you to understanding of microcontroller programming for ARM, Cortex, and core architecture. I will focus on general knowledge, common knowledge, not only on reset line. So I will give you some access to apply the knowledge for any ARM microcontrollers. So next one is requires hardware. In this course, I choose RA41 fast prototyping mode as the starter board. You can see here is RA41 microcontroller. It's almost in out output here. Here is the most important part of the course. This is almost ceiling. You can download the executed image to the microcontroller directly and debug it as well. What you have to do is only a micro USB cable to plug in here. Here is USB, micro USB. If you have custom board, no problem, but you need an external link to flash and debug your custom board, right? So the next one is required software. The first software is Etude Studio. With Etude Studio, we can write the code, build, debug, and flash the binary file to the microcontroller. And we can set some properties and some feature of microcontroller in here. And after that, you generate the code, right? The second software is the Flash. With the Flash, you can download the binary file to the microcontroller for stealing. The installation of the software I will show you detail in the next video. And the last section is all content for this series. The first is system and core. System and core we will explore about ARM Cortex-M33 theory, clock like external clocks, internal clocks, PLL, and so on. About system bus, statistics, timer, interrupt, and ending. Boot mode. you will understand what the reset operation. Mm, So reset procedure before running the main function and print functionality. So next part is peripherals like GPIO, timer, inputs, PWM, input capture, etc. Analog like ADC, DAC, watt timer, RTC, DMA, and DTC. So next is connectivities. It's all of common protocol like UART, SPI, I2C, quick SPI, USB 2.0 full speed, CANS protocol. Mm. About security and encryption, we explore about just rule. This is most important about security and data protection. Next is power management, like reducing power consumption, how to measure and calculate the current consumption, low power modes like sleep mode, standby mode, etc. And about binary, last is memory, like SRAM memory and flash memory. So there are some main content I want to set to run my series and much more on session. I will show you later. If you are interested and my series is useful to you, please give me a subscribe to my channel. Thank you and see you in the next video.